Hello, this movie is for Learning Target 5, Similarity in Right Triangles. And we know right triangles have one right angle, two legs, and the two legs are the two sides, leg 1, leg 2, and the hypotenuse is the longest side opposite the right angle. We did a warm-up in class where we cut out paper and we noticed that triangles A, B, and C were all similar. And we could place A and B on top of C and get that they were all similar. Our altitude here ended up going through our right angle for C. And we noticed that we had sides proportional, angles congruent. With similar right triangles, and you could see in this image, it's our ABC triangles, and then C is the larger. We get similar right triangles, therefore similar corresponding parts. So if we want to write a corresponding parts similarity statement, we're going to have to align and see what the corresponding parts are. When we have an altitude to a right triangle, always hits at a right angle, it makes the right triangle cut into three different parts, three different similar triangles. So we have a small triangle, small right triangle, which is here at A. And that small triangle has the right angle at W. The short leg is XW. We also get triangle B, which is a medium-sized triangle. And we have the right angle at W. The short leg is YW, and it extends to Z. And then we have the large triangle, the large right triangle, where the two smaller ones are sitting on top of, with the right angle at Y, and the short leg is XY, and it extends to Z. So that allows us to write a similarity statement. If I start with triangle XWY is similar to, I did the short leg to the long leg to the hypotenuse, and I would have to do the same over here. Short leg, so YW to Z, is similar to triangle XYZ, because you have to align the corresponding parts. And sometimes with right triangles, it's easier to write it out and make the three different triangles. Before we move on, we're going to learn about something called geometric means. We have algebraic means and geometric means. Proportions in which the means, that's these two, are the same occur frequently in geometry. And we call that the geometric mean. So we would say that X is the geometric mean between the numbers A and B. So if I were to solve for X, I would cross multiply and I get a quadratic. X squared equals A times B. And then to solve for X, I'm going to take the square root of AB. So let's put this into practice. Find the geometric mean between 11 and 8. And what that means is 11 is to a number as that number is to 8. That's essentially what we're finding. So that's how you set it up. And then we cross multiply and solve. And we get X squared equals 88. We're going to square root both sides. And then we're going to simplify this root. And I know 4 goes into 88. So it becomes 4, which is going to be a 2 on the outside. And 4 times 22, so it's 2 root 22. Because this is 4 times 22, and square root of 4 is 2. So here's our simplified root, and our geometric mean is 2 root 22. Pause the movie, try these two, and then press play when you are finished. Okay, the geometric mean between 6 and 15, we say 6 is to X as X is to 15. And we cross multiply, X squared equals 90. X is square root of 90. That is 9 times 10, which is 3 root 10. Down here, 4 is to X as X is to 18. Cross multiply, X squared equals 72. Square root of 72, that's going to be, let's see, 4 times 9 times 2. Square root of 4 is 2. Square root of 9 is 3. So I get 6 root 2. I did that kind of quickly. All right, so simplified root, 6 root 2. Let's go to the next slide. Now, we're going to apply those two ideas together. Here we have similar triangles. We drew the altitude of the right triangle, PQR, and that altitude ends up being a geometric mean. So, note, the altitude of a right triangle is a geometric mean. And I'm going to show you what it's the geometric mean between in the next slide. So our first property, this one's called a corollary because it's a subset of, is this. We've got an altitude, CD. It's an altitude because it's perpendicular to its opposite side. It cuts the right triangle, ABC, such that we have 3 similar right triangles. Now, this altitude right here, if I call this altitude, let's say X, I'm going to cut the hypotenuse into the 2 parts, Y and Z, where point D is cutting it, not in half, but into 2 parts, Y and Z. This corollary says that the X, the altitude, is the geometric mean between the 2 parts of the hypotenuse. So this would be we could write it, there's many ways to set up the proportion, don't forget that. Y is to X as X is to Z. But notice the X is the same across from each other. So when you cross multiply, you get X squared. But many ways to set up that proportion, but that makes the altitude the geometric mean of the 2 parts. So here's an example. We say 2 is to 4 as 4 is to 8. So that 4 is the altitude, and it's the geometric mean between the 2 and the 8. And we just cross multiply. So let's look down here at this example. We've got 7 is the altitude. So what we know is 7 is the altitude or the geometric mean between these 2 values. So I can say X is to 7 as 7 is to 3. Now where this is coming from, if that is confusing, me saying that the altitude is the geometric mean, notice in the 2 triangles, A and B. In triangle A, I've got the short leg and the long leg. In triangle B, this is my short leg and this is my long leg. So I'm really doing triangle A, let's see, 3 and 7. 7 is the long leg, short leg. And then with triangle B, X is the long leg, and this is the short leg. So you can look at it as long leg is to short leg, as long leg is to short leg of the 2 triangles A and B. When you cross multiply, you get 3x equals 49. Divide by 3, and we get x is 16.3 repeating. So multiple ways to set that up. Cross products will give you 16.3 repeating. This is our first corollary. We'll practice that. That says that the altitude's the geometric mean between the 2 parts of the hypotenuse. The second corollary says this. It says that this AC would be the geometric mean between AB, which is this entire hypotenuse. So I'm going to call this G for geometric mean. Between AB, which I'm going to call X, and AD, which I'm going to call Y. So we say X is to G as G is to Y. And notice that the leg of the larger triangle is the geometric mean between the part of the hypotenuse that includes that and the whole hypotenuse. Now what this is using is the two triangles. It's using the large triangle, triangle C. So this large triangle, it's using this one, where this is the hypotenuse of that.
Thomas, please come to the main
And
office.
this is
Thomas, please
the
come to
short
the main office.
leg
Thank you.
of that. Sorry about that interruption. And then it's also using triangle C, where this is the short leg and this is the hypotenuse. So we're saying short leg is the hypotenuse as short leg is the hypotenuse. Now the same is true over here on the other side, where I could do x is to, I'm going to call this, no, I'll call this A, and I'll call this B. Where A is the geometric mean between the hypotenuse and the part of the hypotenuse. So I could say B is to A as A is to X. Multiple ways to write it. It's going to take practice. Okay, over here, in this example, 2 is the geometric mean because it's one of the legs of the triangle. And it's the geometric mean between 1 and 4. So we say 4 is to 2 is 2 is to 1. Let's go ahead and use this example here. Let's get the entire hypotenuse. 8, 9, we get 12 here. And then we are going to say that x is the geometric mean between 12 and 7. So we say 7 is to x as x is to 12. And we cross multiply and we solve. And so we get x squared equals 7 times 12. We get 7. Oh, I'm sorry. This is 11. Whoopsies. I think the announcement threw me for a loop. So we get 77. So we get x equals square root of 77, which is 7 times 11, which does not simplify. We leave it square root of 77. But notice what we did here. This leg is the geometric mean between the hypotenuse and this. So it's long leg is to hypotenuse as long leg is to hypotenuse. All right, pause the movie, solve for x and y, and then press play when you are finished. All right, to solve for x, we say x is the geometric mean between the entire length, which is 16, and the 4. So 4 is to x as x is to 16, and we cross multiply and we get x squared equals 64, so x is 8. Or we're solving for y. Now y would be the geometric mean between 12 and 4. So we do 12 is to y as y is to 4. We cross multiply, and this is 48. Square root of 48 is 16 times 3, which is 4 root 3. So this would be 4 root 3. All right. Pause the movie, try these, and press play when you are finished. Okay, to solve for x, x is the geometric mean between the whole hypotenuse and 4. So we've got 9 here. So we say 4 is to x as x is to 9, and we cross multiply, and we get x squared equals 36, x equals 6. To get y, y is the geometric mean between 4 and 5. So 4 is to y as y is to 5. And we cross multiply and we get x, or y squared, is equal to 20. 20 is 4 times 5, so it's 2 root 5. 2 root 5. And this is a great extension problem. I want you to pause the movie. Now keep in mind this whole length is 9 plus x. Pause the movie and then press play when you are finished. All right, in setting this up, you would have x is to 20 as 20 is to x plus 9. And when you cross multiply, you get the quadratic equation x squared plus 9x minus 400 equals 0. And when you solve that, you get x is 16 and x is negative 25, but only one of these works. 16 does. And that's all for this movie. Thanks for watching.